Hello everyone. Today I am here with you all with the second chapter of class 9th, that is polynomials. So before starting with it, let's understand some of the terminologies related to it. Constants. Constants are the numbers whose values remains the same throughout. Means whatsoever the situation we are using it, its value will be same. So all the numbers, all the numeric values like your 2 is there, 5 is there, minus 3 upon 2, or you can say 5 upon 7. All these are your constants because wheresoever we are going to use, in whatsoever the situation we will be using these numbers, their value will be same. 2 will be same throughout wheresoever you will use it. 5 will be 5 wheresoever you use it. So all these numbers whose value remains same, remain constant throughout the situations. These type of numbers are known as your constants. Variables. As the name suggests, its value varies. If the situation changes, its value even changes. It is denoted by your alphabets like X, Y, Z, A, B, C. All these are your variables. If we are going to change the situation, their value will even change. It's not same throughout the situations. Like the value of X could be your 2 even, the value of X could be your 3 even, the value of X could be 7 by 2 even. Whatsoever the value we want to keep for all these variables, we can keep, and as per the situation, their values changes or varies. That's the reason they are known as your variables. Like if I am going to say 2x is equivalent to 4. In this condition, the value of x is your 4 upon 2, that is your 2. And if I am going to say 2x is equivalent to 6, in this condition, value of x will be 6 upon 2, that is 3. So the variable is same, that is x only, but in this situation, the value of x is your 2. In this situation, the value of x is 3. So because their value varies as per the situation, that's why they are known as your variables. Now terms. When we are combining the constants and the variables using your multiplication sign and the division sign, we are getting terms. Over here we can see if I am going to say 2x square y. Over here 2 is multiplied by x multiplied by x multiplied by y. How we can write it as 2 multiplied by x multiplied by x multiplied by y. So when we have multiplied or divided the constants and the variables, over here 2 is the constant, x is your variable, y is even variable, we have multiplied all this, so whatsoever we are getting is your term. Similarly, if I am going to say minus 5 over 3 x square divided by y, this is even a term in which minus 5 upon 3 is the constant, x square is a variable, x is a variable, and y is even a variable. So we have, what we have done is, we have minus 5 over 3 multiplied by x divided by y. So when we are multiplying or dividing the constants and the variables, the thing which we are getting is your terms. These are known as your terms. Now what coefficients are? See, if I am going to say, I am going to take this term 2x square y, and we have to find the coefficient of y in this term. We have to find the coefficient of y. So if I'll be dividing this whole term by y, whatsoever I'll be getting will be the coefficient of y. So coefficient of y in this case, coefficient of y, if I am going to consider, it will be 2x square y over y, that is your 2x square will be the coefficient of y. If I am going to say what will be the coefficient of your x square, so coefficient of x square will be 2x square y divided by x square, that is 2y will be the coefficient of your x square. If I'll be saying what will be the coefficient of x square y, so obviously we can see 2x square y divided by x square y, that means 2 will be the coefficient of your x square y. Similarly, if I am going to say x minus of 5x, so over here coefficient of x will be minus of 5. Coefficient of x will be your minus of 5 will be the coefficient of your x. So this is how we can find the coefficient of any variable, any constant, whatsoever we want, we can find the coefficient. Now what algebraic expressions are? So when we are either adding or subtracting your terms, we are getting algebraic expression. Like if I am going to say 2x square y plus 3x minus 5. Over here 2x square y is one of the term, 3x is one of the term, 5 is one of the term. So if we have added or subtracted these terms together, the expression which we are getting is known as your algebraic expression. Similarly, I can see like minus 5x plus 3x square minus of 7. This is even an algebraic expression. Over here, this is one of the term, this is one of the term, this is one of the term. When we have added and subtracted the terms, the expression which we are getting is your algebraic expression. Similarly, x raised to the power 3 by 2 minus 5 is even an algebraic expression. Or we can say minus of 5 x raised to the power minus 3 plus 3x square minus of 7 is even an algebraic expression. So whensoever we are either adding or subtracting your terms, we are getting algebraic expressions. Now let's see what polynomials are. Polynomials are the special cases of your algebraic expression in which the exponent or the power of the variables is always a whole number, where the power, or you can say exponent, of your variables is whole number. If this is the case, then these algebraic expressions are known as your polynomials. That means all the polynomials are your algebraic expression, but all the algebraic expressions are not polynomials. If I am going to see over here, in this, the variables is either your x or y. These are the variables, and the power or the exponents of the variables is whole number, because over here its power is 2, power of x is 2, power of y is 1. Here power of x is 1. So it is a polynomial because the power of the variables is whole number. If we are going to take this example, over here the power of x is 1, here power of x is 2. This could even be written as minus 7, could even be written as minus 7x raised to the power 0. Because x raised to the power 0, any number or any variable raised to the power 0, its value will be 1. So here also the power of x is your 0, which is a whole number. So that's the reason this is even an polynomial, because all the powers of the variables is a whole number. But if we are going to see this example, in this x raised to the power 3 by 2, the power of the variable is your 3 by 2, which is not a whole number. It is a fraction. 3 by 2 is a fraction. That's the reason it is not a polynomial. It is an algebraic expression, but it is not a polynomial. Similarly, over here, if we are going to see, in this, power of x is your minus 3. Minus 3 is an integer. It is not a whole number. That's why this is even not an example of your polynomial. It will be an algebraic expression, but it will not be a polynomial. So what we can conclude is polynomials are the special cases of algebraic expression in which the power of the variables cannot be negative. It cannot be in fractions. So if the powers of the variables is only whole number, it could be 0, it could be 1, it could be 2, it could be any whole number. If it is the case, then such type of algebraic expressions are known as your polynomials. Now let's understand various types of polynomials on the basis of number of terms. First is your monomial. If in the polynomial number of terms is your 1, if there is only one term in the polynomial, then such type of polynomials are known as your monomials. Like example could be your 2x. It is only one term. If this is the polynomial, in that case this polynomial will be monomial because it is having only one term. Similarly 7y, or you can say 5 upon 3, or your 3x square y, all these are having only one term. So such type of polynomials which is having only one term are known as your monomial. The term should be your non-zero. The non-zero number, non-zero term of any of the polynomial, if it is having only one non-zero term, in that case such type of polynomials are known as your monomials. If the number of terms is your 2 in any of the polynomial, then it is known as binomial, like your 3x square plus 5x. in this polynomial, there are two terms are there. 3x square is one of the term, 5x is another term. So if the number of terms in any of the polynomial is 2, then such type of polynomials are known as binomial. Another example could be 7y square minus 5. This is even an example of binomial because it is even having two terms. One is your 7y square, another is your minus of 5. Another could be your 3x plus 5. It is even a binomial because the number of terms is your 2. So whensoever we are having two non-zero terms in any of the polynomial, then such type of polynomials are known as binomial. Now let's see what is trinomial. If the number of terms is 3, we know tri means 3 only. So if the number of terms in any of the polynomial is 3, then such type of polynomials are known as trinomial. Like example could be 3x raised to the power 7 minus 5x raised to the power 3 minus 75. If this is we are talking about, so in this polynomial there are three terms are there. One is your 3x raised to the power 7, another is minus 5x raised to the power 3, and the third one is your minus of 75. So there are three non-zero terms in the polynomial. So such type of polynomials are known as your trinomials. Another examples we can take it as x cube minus 3x square plus 7x. This is even an example of trinomial because there are three terms. So whensoever we are having exactly three non-zero terms in any of the polynomial, then such type of polynomials are known as your trinomials. Now, if we are going to see, mono means your one only, bi means your two. So if number of terms is 1, it is monomial. If number of terms is 2, it is binomial. Tri means 3. So if number of terms is 3, it is your trinomial. But over here, monomial cannot even be means it is a special case of polynomial. But whenever we are saying binomial or trinomial, these are even known as your multinomials, because see, multi means more than one, right? So it is having only one term. So this is monomials is not known as your multinomials, but binomials and trinomials could even be known as your multinomials, because it is having more than one terms. So all the polynomials which is having more than one term, it is known as your multinomials also. Now, what is the standard form of writing any of the polynomial? So whensoever we are arranging the variables in terms of ascending order or descending order, then such type of expression, such type of representation is known as standard form. Like if I am going to write, this is in the standard form because over here the first x raised to the power 7, then x raised to the power 3, then over here we can say it as x raised to the power 0. So the powers of x is decreasing, it is in descending order. So this is in its standard form. Similarly, this is even in standard form because here the power of x is 3, then here 2, then here it is 1. So whenever we are representing any of the polynomial, either in the ascending order of the power of the variable or in the descending order of the power of the variable, such representations are known as your standard form of the polynomial. Like if I am going to say 3x raised to the power 5 minus 5x raised to the power 7 minus 3x raised to the power 2. So it is not in its standard form, because over here x raised to the power 5, then it is increasing x raised to the power 7, then it is decreasing x raised to the power 2. So it is not in its standard form. If we have to represent this polynomial in its standard form, first of all we will be writing this with the highest power of x minus 5x raised to the power 7, then your plus of 3x raised to the power 5, then minus 3x raised to the power 2. So whensoever we are representing any polynomial with either the increasing order of the power of the variable or the decreasing order of the power of the variable, then such type of representation is known as your standard form of the polynomial. Now let's understand what is degree of the polynomial and what all are the types of the polynomial on the basis of degree. So degree is the highest power of the variable in any of the term of the polynomial is known as degree of the polynomial. Like suppose I am going to take an example, 2x raised to the power 5 plus 3x raised to the power 2 minus of 5x. In this, there are three terms are there. This is first term, this is another term, and this is the third term. Over here in the first term, the power of the variable x is your 5, In the second term, the power of the variable x is 2. In the third term, power of the variable x is your 1. So in this polynomial, the highest power of the variable in any of the term is your 5. That's the reason degree of this polynomial will be 5. Similarly, if I am going to take another example, 5x raised to the power 11 minus of 8x raised to the power 7. Here there are two terms are there. For this term, the power of the variable x is your 11. And for this term, the power of the variable x is your 7. So highest power of any of the term is your 11. That's the reason degree of this polynomial will be 11. So whatsoever is the highest power of the variable in any of the term of the polynomial, that highest power is known as degree of the polynomial. So here we have taken the cases when there is only one variable. If there are two variables or more than two variables, how we can find the degree of the polynomial? Say I am going to take an example, 3x square y cube z raised to the power 2 plus 4x cube y4 z3 minus 8 x raised to the power 2 y raised to the power 3 and z. If this is a polynomial, it is a polynomial in three variables, that is your x, y and z. Now how to find the degree of this type of polynomials? So what we will be doing is we will be adding the powers of all the variables. Here power of x is 2, y is 3 and z is 2. So we will be adding all this, that is 2 plus 3 plus 2. That will become 7. So for this term, the highest power will be your 7. For this term, the power of the variable will be 7. Now for this term, it is x raised to the power 3, y raised to the power 4, z raised to the power 3. So we will be adding all this. The 4 plus 3, 7. 7 plus 3, it will be 10. So power of the variable will be your 10 in this case. For this term, it is your x raised to the power 2, y raised to the power 3 and z. So 2 plus 3 plus 1. Z means z raised to the power 1. So 2 plus 3, 5 plus 1, 6. For this term, it is your 6. So highest power of the variables is your 10. That's the reason for this polynomial degree will be your 10. This is how we can calculate the degree of any of the polynomial, if it is in one variable or if it is in two variable or three variable, whatsoever the condition is. Now on the basis of degree, how we can bifurcate the polynomials? First is your zero polynomial. So if a polynomial is in terms of your x we are talking about, then it is written as your px. So px equivalent to 0 is your zero polynomial. That means whatsoever the number of terms are there, if the coefficient of all the terms is 0, then such type of polynomials are known as your zero polynomial. Like if I am going to take an example, 0 multiplied by x raised to the power 3 plus 0 multiplied by x raised to the power 5 minus 0 multiplied by x raised to the power 2. If this is the polynomial, here three terms are there, but in all the three terms your coefficient is 0. For x cube coefficient is 0, for x5 coefficient is 0, for x square coefficient is 0. So all the terms will become equivalent to 0 only. So such type of polynomials is known as your zero polynomial. When the coefficient of all the terms is 0, such type of polynomials is zero polynomial, and it is denoted by px is equivalent to 0 only. Now, if we are going to see the degree of this polynomial is not defined. We cannot define the degree of zero polynomial, because see, if we are going to see this term, here power of variable is 3, here power of the variable is 5, here power of the variable is 2. But instead of, so for this condition it is 5 we can say, but this could even be written as x raised to the power 10 also, right? So if in this case your degree will become 10. So that's the reason we cannot define the degree of your zero polynomial, because it could even be written as your plus 0 multiplied by x raised to the power 15. In that case it will become 15. So that's the reason we say that the degree of a zero polynomial is not defined, and whensoever your polynomial is like px is equivalent to 0, this is your zero polynomial. Now the maximum number of terms in the zero polynomial again we cannot define, because there could be any number of terms in it. Now coming to your constant polynomial. So whenever we are writing any polynomial in x, px is equivalent to any constant number. It could be your 5, it could be your minus 7 upon 3, it could be your 5 upon 7, whatsoever the numbers are, we can take any constant number. So such type of polynomials are known as your constant polynomial. In these type of cases, your degree of the polynomial will be 0. Why it is 0? Because see, 5 could even be written as 5 multiplied by x raised to the power 0. Any base with the power 0 is equivalent to 1. We know that. So 5 multiplied by 1 will be 5 only. So it could be written as 5 into x raised to the power 0. And as we are saying, degree is the power of the variable. And power of the variable over here is your 0. That's the reason degree of the constant polynomials is 0. And maximum number of terms in a constant polynomial will be 1. There could be only one term in a constant polynomial because there won't be any term with your variable x. If it will become your, suppose I am writing this as 5 upon 7 plus x. So there will be two terms and the degree will become your 1 in that case. That's the reason it is not an example of your constant polynomial. So we can say that the maximum number of terms will be your 1 only and the degree of a constant polynomial will be 0. Now coming to linear polynomial. Linear polynomials are the polynomials whose degree is 1. If there is any polynomial whose degree is 1, then such type of polynomials are known as linear polynomial. Example, we can take px is equivalent to 3x plus 5. This is an example of linear polynomial because it is having two terms. For the first term, your degree power of the variable is 1. For the second term, power of the variable is 0. So maximum power of the variable is 1. That's the reason degree of this polynomial is 1. And if the degree of the polynomial is 1, such type of polynomials are known as linear polynomials. Now the standard form of the linear polynomial is ax plus b. It is the standard form of the linear polynomial where a and b are any real numbers and a cannot be 0. Why a cannot be 0? Because see, if a will be 0, in that case, this term will become 0. If a will be 0, this term will become 0 because 0 multiplied by x will be 0 only. In that case, your polynomial will be a constant number only. Because just now we have said that a and b both are any real numbers. So it will be any real number only. That means it will become a constant polynomial instead of your linear polynomial. So the condition for a linear polynomial is that the standard form of the linear polynomial will be ax plus b, where a and b are any real numbers and a cannot be 0. That means coefficient of x cannot be a 0. And maximum number of terms in a linear polynomial will be 2. It is a maximum number of terms, but it could be 1 also, but it cannot be 3. Maximum number of terms will be your 2 only. It can be 1 also. Like if I am going to say px is equivalent to 3x, it is even a linear polynomial. Although it is having only one term, but still it is a linear polynomial because the degree of the polynomial is 1. So maximum number of terms is 2. It could be 1 also. And the standard form of the linear polynomial is ax plus b, where a and b are any real numbers and a cannot be 0. Now let's see what is quadratic polynomial. The polynomials with degree 2. If the degree 2 is type of any of the quadratic polynomial, then we say it to be a quadratic polynomial. That means if there is any polynomial, say px, say 2x square plus 3x plus 5. This is a polynomial. Here we can see the degree of this polynomial is 2. That's the reason this polynomial is an example of your quadratic polynomial. It is having 3 terms. For this term, the power of the variable is your 2. Here, power of the variable is 1. Here, power of the variable is 0. So, maximum power of the variable is 2. That's the reason degree is 2. And if degree is 2, the polynomial is your quadratic polynomial. Another example even we can take in y. It could be 3y square plus 5y minus 7. This is even an example of your quadratic polynomial. So we can see that the standard form of the quadratic polynomial in terms of x, it will be ax square plus bx plus c. This is an example of your standard form of your quadratic polynomial where a, b, c are any real numbers and a cannot be 0. See, because if a will become 0, your this term will become 0. And if this term is becoming 0, in that case, it will not be a quadratic polynomial. It will become a linear polynomial. That's the reason standard form of the quadratic polynomial is px is equivalent to ax square plus bx plus c, where a, b, c are any real numbers and a cannot be 0. Coefficient of x square cannot be 0, because if it will turn to 0, it won't be a quadratic polynomial. Its degree will not be 2 in that case. So if the degree is 2, these type of polynomials are known as your quadratic polynomials. Now coming to cubic polynomial. So any polynomial whose degree is 3 are known as cubic polynomial. Example, we can take px is equivalent to 3x cube minus 5x square plus of 5x minus of 7. If this is the polynomial, here we can see the degree of this polynomial is 3, because highest power of the variable in this polynomial is 3. That's the reason its degree is 3, and if degree is 3, it is known as your cubic polynomial. Standard form of the cubic polynomial is given by ax cube plus bx square plus cx plus d. Again, a, b, c and d are any real numbers and a cannot be 0. Coefficient of x cube cannot be 0, because if this will become 0, it will become a quadratic polynomial instead of a cubic polynomial. So that's why this is the standard form of the cubic polynomial, and where a, b, c, d are your any real numbers and a cannot be 0. Here again we can see that the maximum number of terms will be 4. 1, 2, 3, 4. 4 will be the maximum number of terms. It could be 3 also, it could be 2 also, it could be 1 also, but it cannot be 5. So maximum number of terms in the case of cubic polynomial will be 4. And in the case of quadratic polynomial, maximum number of terms will be 3. 1, 2, 3. Maximum number of terms will be 3 in case of quadratic polynomial. It could be 2 also, it could be 1 also. For 2, we can take an example. 2x square minus of 5. It is even a quadratic polynomial, right? Similarly, cubic polynomial, just now we said ax cube plus bx square plus cx plus d is the standard form of the cubic polynomial, where a, b, c, d are any real numbers and a cannot be 0. Maximum number of terms will be 4. It could be 3, it could be 2 also. Like take an example, 3x cube minus of 5. It is even an example of your cubic polynomial, although it is having only 2 terms. And if it is only 3x cube, then also it is an example of your cubic polynomial, although it is having only 1 term. So maximum number of terms could be 4, but it could be less also. Now coming to biquadratic polynomial. Biquadratic polynomials are the polynomials whose degree is 4. If the degree of the polynomial is 4, then such type of polynomials are known as biquadratic polynomial. Example, we can take, say 2x raised to the power 4 minus of 5x raised to the power 3 plus of 7. This is a biquadratic polynomial because its degree is 4. And the standard form of the biquadratic polynomial will be px is equivalent to ax raised to the power 4 bx cube plus cx square plus dx plus e, where a, b, c, d, e are any real numbers and a cannot be 0. The same reasons we are having, because if this term will become 0, it will become a cubic polynomial instead of biquadratic polynomial. So if there is any polynomial whose degree is 4, then such type of polynomials are known as biquadratic polynomial. We can see over here that the maximum number of terms in a biquadratic polynomial will be 5. It could be less than that, but it cannot be more than 5. So maximum number of terms will be 5. Ax raised to the power 4 bx cube plus cx square plus dx plus e will be the standard form of the biquadratic formula polynomial in terms of x, where a, b, c, d, e are any real numbers and a cannot be 0. Now let's understand what is value of the polynomial and what is 0 of the polynomial. if there is any polynomial in terms of x, that is px is any of the polynomial, and if we are going to replace this x by any of the real number, say we are taking a real number a, and if we are going to replace this x by a, whatsoever the value of the polynomial we are getting will be known as value of the polynomial px at x is equivalent to a, and it is denoted by your pa. That simply means if px is a polynomial and if a is any real number, then value obtained by substituting x is equivalent to a in px is called value of px at x is equivalent to a and is denoted by pa. Now let's understand with an example. Suppose there is a polynomial px is there. It is equivalent to your 2x square plus 3x plus 5. If this is a polynomial, and we have to find the value of this polynomial at x is equivalent to 1. In that case, this will become your p1, and it will be, we will be replacing this x by your 1. So 2 multiplied by 1 is square plus 3 multiplied by 1 plus of 5. This will be 2 into 1 square will be 1. So 2 plus 3 plus 5. 2 plus 3 is 5 and 5 plus 5 is 10. That means value of this polynomial at x is equivalent to 1 is p1 is your 10. This will be the value of the polynomial. So we will say that p1 is your 10. Similarly, if another polynomial we are taking, suppose I am taking another polynomial, say 3x square minus of 5, and we have to find its value at x is equivalent to 2. Then what we will be doing is, wheresoever x is coming, we will replace this x by 2. So this will be p2. 3 multiplied by 2 square minus of 5. 2 square will be 4 and 4 3s are 12. So 12 minus 5, it will be your 7. So value of the polynomial px is equivalent to 3x square minus 5 at x is equivalent to 2. That means p2 is 7. This is how we will be getting value of any polynomial at any given real number. What we will be doing is, wheresoever the variable is coming, we will replace that variable by the real number of which we have to find the value, and whatsoever the final value will be there, that will be the value of that polynomial at that particular real number. Now let's see what is 0 of the polynomial. Now over here we have seen how to find the value of the polynomial. If for any real number the value of the polynomial becomes 0, like over here value was coming equivalent to 10, over here value was coming equivalent to your 7. If the value of the polynomial becomes equivalent to 0 for any real number, then that particular real number is known as 0 of the polynomial. Like 0 of a polynomial px is a number c such that pc equivalent to 0. If we are going to replace the x by c and value of pc becomes equivalent to 0, then this c is known as your 0 of the polynomial, or it is the value of variable which when substituted in a polynomial makes its value 0. Now let's understand. Suppose I am taking an example, px is equivalent to 2x square plus 3x minus 5. If I am going to find its value at x is equivalent to 1, then what p1 will be? P1 will be 2 multiplied by 1 square plus 3 multiplied by 1 minus of 5. It will be 2 plus 3 minus 5. 5 minus 5, it will be 0. So value of this polynomial 2x square plus 3x minus 5 at x is equivalent to 1 is your 0. When we are replacing this x by 1, its value is becoming equivalent to 0. That means for this polynomial, 0 of the polynomial is your 1. 1 is the 0 of this polynomial, because when we are replacing x by 1, the value of the polynomial is becoming equivalent to 0. Similarly, one more example we can see. Say px is equivalent to x minus 5. Now, if I will replace this x by 5, so what the value of p5 will be? 5 minus 5, that is equivalent to 0. That means if I am replacing this x by 5, the value of this polynomial is becoming equivalent to 0. That simply means x is equivalent to 5, or we can say 0 of this polynomial is your 5. 5 is the 0 of the given polynomial. So 0 is any real number which when replaced by the variable makes the value of the polynomial equivalent to 0. So these are the zeros of the polynomial. Now here we are simply writing px is equivalent to x minus 5 or px is equivalent to this. So these are the polynomials in terms of x. If we will equate it equivalent to your 0, like if I am saying instead of this x minus 5, I am equating it equivalent to 0, then it becomes an equation. Whenever we are equating it equivalent to 0 or any other polynomial, then it is your equation. And whatsoever is the 0 for this polynomial will be the root of this equation. That simply means over here, if I am going to solve the LHS part, that is your x minus 5, and if I replace x by 5, in that case your LHS will become 5 minus 5, that is 0, and it is equivalent to your RHS. That means if I am going to replace the variable x by 5, your LHS part will become equivalent to your RHS part, or this is the solution of this equation, or this is the root of this equation. For this, root of equation will be your 5. That means whatsoever is the 0 of the polynomial, that will be the root of the equation also, if your polynomial, this polynomial is same and it is only equivalent to your 0. If like this we have generated the equation, then whatsoever the 0 of the polynomial will be the root of the equation also. Now if we are going to talk about your linear polynomial, just now what we have seen is ax plus b. This is the standard form of any of the linear polynomial. So for a linear polynomial, maximum or minimum means at least or at most, we are having only one root. Not root, basically if we are talking about polynomial, so it will be 0. So for a linear polynomial, we will be having 1 0. 1 0 we will be having. How we will be getting its value? If I will equate it equivalent to 0, so we can say ax will be equivalent to minus b and x is equivalent to minus b by a. That simply means if I am going to replace x by minus b upon a, then the value of the polynomial will become equivalent to your 0, and that means x is equivalent to minus b upon a is the 0 of a linear polynomial if your polynomial is your ax plus b. If we are having a linear polynomial ax plus b, then 0 of this polynomial will be minus of b upon a. Now just check it out. If I am going to replace x by minus b by a, so it will be minus b by a multiplied by, instead of x I will be writing minus b by a plus b, a and a cancelled, minus b plus b, it is equivalent to 0. That means for a linear polynomial, which is your ax plus b, the 0 of the polynomial will be minus b upon a. And for a linear polynomial, we are having 1 0. If we are talking about a quadratic polynomial means whose degree is 2. And the standard form of a quadratic polynomial was ax square plus bx plus c. This was the standard form of your quadratic polynomial. For a quadratic polynomial, maximum of 2 zeros we are having. It could be less than that even, it could be 1 0 also. There could be no real 0 even possible. But at the max, we will be having 2 zeros. Maximum of 2 zeros we will be having for a quadratic polynomial. Similarly, if we are going to talk about a cubic polynomial, that means whose degree is 3. So maximum of 3 zeros are possible for a cubic polynomial. That means 3 is maximum. It could be 2, it could be 1, but maximum of 3 zeros will be there, which is going to satisfy your polynomial. That means maximum of 3 values of the variable will be there, for which your polynomial will become equivalent to your 0. Right? For a linear polynomial, it will be 1 value. For the quadratic polynomial, maximum of 2 zeros are possible. That means maximum of 2 values of the variable will be there, for which your polynomial will become equivalent to 0. For a cubic polynomial, maximum of 3 values of the variable will be there, which is going to satisfy your polynomial. That means for which the value of the polynomial will become equivalent to 0. Now, if we are going to talk about the constant polynomial, say I am saying 5. 5 is a constant polynomial. So there is no value of the, because what 5 could be written as? 5 could even be written as 5x raised to the power 0 also. right? 5 multiplied by x raised to the power 0. Now, if I am going to take any number of x, for any number of x, your value will not become equivalent to 0, right? Because see, if I am going to take x is equivalent to say 2, so the value will be 5 multiplied by 2 raised to the power 0, that is your 5 only. That means there is no 0 for a constant polynomial. For any of the constant polynomial, there is no 0 exist. That means whatsoever the value of the variable you are going to keep, its value will be equivalent to the constant only. It is never ever going to come equivalent to 0. That means for a constant polynomial, no zeros are possible. There is no value of the variable for which your polynomial will turn to 0 for a constant polynomial. Now, if we are going to talk about a 0 polynomial, this was your constant polynomial, that was px is equivalent to 5. So no 0 is possible for any of the constant polynomial. Now, if we are going to talk about a 0 polynomial, so whatsoever the real number comes in your mind is the 0 of the 0 polynomial. Why? See, over here 0 could be this could be written as 0 multiplied by x raised to the power 5 plus 0 multiplied by x raised to the power say 2. Suppose this is. Now, if I am going to replace x by 5, suppose I am replacing x by 5, so 0 multiplied by 5 raised to the power 5 will be 0. 0 multiplied by 5 raised to the power 2 will be 0. That means value of the polynomial will be 0. If I am going to replace this x by say 7 upon 3, in that case 0 multiplied by 7 upon 3 raised to the power 5 will be 0. 0 multiplied by 7 upon 3 raised to the power 2 will be 0. That means value of the polynomial will be 0. That means every real number is 0 for the 0 polynomial, and there is no value of x, no value which is the 0 of a constant polynomial. For a linear polynomial, we are having only 1 0. For a quadratic polynomial, maximum of 2 zeros we are having. For a cubic polynomial, maximum of 3 zeros we are having. Whatsoever will be the degree of the polynomial, that will be the maximum value of zeros. Maximum number of zeros will be that only. That means if degree of the polynomial is say 7, if the degree of a polynomial is 7, that simply means maximum of 7 values of the variable you will be getting for which your polynomial will become equivalent to 0. Now let's understand what is remainder theorem. According to the remainder theorem, if a number a is substituted for x in the polynomial px of degree greater than or equal to 1, that means we have taken a polynomial px in terms of x whose degree is either 1 or greater than 1, and if we are going to replace this x by a, in that case whatsoever the value of pa we will be getting, then the result pa is the remainder that would be obtained by dividing px by x minus a. That means if we will be dividing a polynomial px by your x minus a linear polynomial, then the remainder of this division will be equivalent to your pa. If we will be replacing this x in the polynomial by a, then whatsoever the value of pa we will be getting, it will be the remainder when we will be dividing your px by your x minus a. Remainder will be your equivalent to pa. How we are taking the value of pa? A over here is the 0 of your divisor. 0 of the divisor. If I am taking x minus a equivalent to 0. X minus a equivalent to 0, that simply means value of x will be your a. That means if we are going to replace this x by a, your polynomial will become equivalent to 0. That means x is equivalent to a is the 0 of your divisor. So if we are going to replace your x by the 0 of your divisor, then whatsoever the value we will be getting, it will be equivalent to your remainder of this division. Now let's take an example. Suppose I am going to say a polynomial is there, that is your say x square plus 3x plus 5. And if we have to divide it by say your x plus 1. This is the division which we have to make. So let's see how the division will be. X plus 1 we have taken as a divisor. Here x square plus 3x plus 5 we have taken. So first of all we have to eliminate this x square. For that, x should be multiplied by x to get your x square. So x multiplied by your x multiplied by x will be your x square, and x multiplied by 1 will be your x. Now subtraction, so sign will be changed. This is going to be removed. 3x minus x will be your 2x plus 5. Now x will be multiplied by 2 to get your 2x. So we will be multiplying it by 2. 2 multiplied by x will be 2x, and 2 multiplied by 1 will be your 2. Again change the sign. This is going to be removed. 5 minus 2 will be your 3. This is the remainder. Now see over here, when we are dividing this polynomial px by your gx, that is your x plus 1, in that case your remainder is coming equivalent to 3. And when we are saying, if we are going to replace this px is equivalent to x square plus 3x plus 5. If we are going to replace x by 0 of your divisor, then what the value will be equivalent to your remainder. Just check it out. What is the 0 of your divisor? If I am going to take x plus 1 equivalent to 0, so value of x will be minus 1. That means 0 of your divisor is your minus 1. X is equivalent to minus 1. That means if I will be replacing this x equivalent to minus 1, in that case your polynomial will become equivalent to 0. So if I will be replacing this x by minus 1, the value will be equivalent to your remainder. Just check it out. Now replace it by minus 1. So p minus 1. Wheresoever x is coming, we will be keeping minus 1. So it will be minus 1 whole square plus 3 multiplied by minus 1 plus 5. Minus 1 square will be 1 only. 3 multiplied by minus 1 will be minus of 3 plus of 5. 5 plus 1 is 6 minus 3, that is 3. This was only the remainder. So this is how without division we can find the remainder of the polynomial. If we are going to divide any polynomial in px whose degree is either greater than or equivalent to degree of your divisor, and divisor should be your linear polynomial, in that case whatsoever the 0 of your divisor is, if you are going to replace your x in the dividend by that value, then we will be getting the remainder. Either by this method you can find the remainder, or by this method you can find the remainder. In both the cases your remainder will be same. Let's take one more example. Suppose I am saying your px is 2x square plus say 5x plus 3. Suppose this is your polynomial, and if we are going to divide it by say x plus 2, if we will be dividing these two, then what the remainder will come? X plus 2 divided by your 2x square plus 5x plus 3. Now first of all we want 2x square. For that we need to multiply this x by your 2x. So x multiplied by your 2x will be 2x square. 2x multiplied by 2 will be your 4x. Just change the sign. It is going to remove. 5x minus 4x will be your x plus 3. Now here x, that means we need to multiply it by 1. 1 multiplied by x will be x. 1 multiplied by 2 will be 2. Change the signs. 3 minus 2 will be 1. So remainder over here is 1. And how we can get this remainder? From here, from this divisor, we will be taking 0 of the polynomial. Now 0 of this polynomial will be x is equivalent to minus 2. Minus 2 will be 0 of this polynomial, because if we will replace this x by minus 2, this polynomial will turn to 0. So 0 of this polynomial is your minus 2. Now we will be taking your px, your dividend. Px is equivalent to 2x square plus 5x plus 3. Now instead of x, we will be replacing this x by minus 2. Whatsoever the value will come, that means value of p minus 2 will give us the remainder. Now we have kept it p is equivalent to x is equivalent to minus 2. So wheresoever x is coming, we will replace it by minus 2. So 2 multiplied by minus 2 whole square plus 5 multiplied by minus 2 plus 3. So minus 2 square will be plus 4. 4 multiplied by 2 will be your 8. 5 multiplied by minus 2 will be minus of 10 plus of 3. 8 plus 3 is 11 minus 10, that is 1. So this is how we can get your remainder. Either by this method we can find the remainder, or directly even without dividing, basically we can find the remainder. This is only your remainder theorem. That means if we are going to divide any polynomial in x whose degree is greater than or equivalent to your divisor, in that case if we are going to replace this x in the dividend by the 0 of your divisor, whatsoever the value we will be getting, it will be equivalent to the remainder. Basically we know what dividend is. Dividend could be written as your divisor multiplied by quotient plus remainder. This already we have learned in our previous classes. So if dividend is your px and divisor is your gx, that means if there are px and gx are two polynomials where your gx is not equivalent to 0, that means your divisor should not be equivalent to 0, such that degree of px is greater than equivalent to degree of gx. Degree of your dividend should be greater than or equivalent to the degree of your divisor. Then two polynomials qx and rx exist such that px is equivalent to gx multiplied by qx plus rx. That means this was your dividend is equivalent to divisor multiplied by qx is your quotient plus rx is your remainder, where rx will either be 0 or the degree of rx will be less than the degree of your gx. That means degree of remainder will be less than the degree of your divisor. Right, now we can check it from this even. Over here, first I am taking this example. Here this is your dividend, this is your divisor, this is the quotient and this is the remainder. So first of all what I am doing is I am taking the RHS part. This part I am taking. Divisor is your x plus 1 multiplied by quotient is your x plus 2 plus remainder is your 3. If I am going to solve it, it should be equivalent to your dividend. Just check it out. X multiplied by x will be your x square. X multiplied by 2 will be 2x. 1 multiplied by x will be x. 1 multiplied by 2 will be 2 plus 3. So it is x squared. 2x plus x will be your 3x and 2 plus 3 will be your 5. X squared plus 3x plus 5. That means we can say it is applicable for your polynomials even. That means polynomial px, that is your dividend, is equal to divisor multiplied by quotient plus remainder. If we will be solving this part, it will be equivalent to the dividend. This is how it can be done. Hope it is clear what is remainder theorem. Now let's understand the factor theorem. According to the factor theorem, if px is a polynomial of degree greater than equivalent to 1 and a is any real number, then x minus a will be the factor of px if pa is equivalent to 0. That means if pa is equivalent to 0, then x minus a will be factor of the polynomial px whose degree is greater than or equivalent to 1. Or pa will be 0 if x minus a is a factor of px. That means if x minus a is the factor of px, in that case pa will be 0, or if x minus a is the factor of px, in that case pa will be 0. Now let's understand this, how we can prove it. Just now we have seen that dividend is equivalent to divisor multiplied by quotient plus your remainder. Just now we have seen that it is px is any of the polynomial whose degree is greater than equivalent to 1. If we are going to divide this by your gx, which is the divisor, if we will be dividing this px by gx, then we will be getting two polynomials. One is your qx and rx, such that px is equivalent to gx multiplied by qx plus your rx, where gx could not be 0 and the degree of your r will be less than the degree of your gx. Now let's see what we have seen just now in the remainder theorem, that if we are going to divide this polynomial px by x minus a. Here divisor we have taken as x minus a. So if we will be dividing this dividend px by your x minus a, then some quotient will be there and remainder will be your pa. That means if we are going to replace this x of this polynomial by a, which is 0 of your divisor, in that case whatsoever the value we will be getting will be the remainder of your division of your px and x minus a. Just now in the remainder theorem we have seen that the remainder will be your pa will be the remainder. Now what is the factor? Now suppose I am going to divide 12 by say 4. So we know that the result will be your 3, quotient will be 3. Here 12 is your dividend, 4 is the divisor and 3 is the quotient. And because it is 12 is completely divisible by 4, that's the reason your remainder will be 0. That simply means whensoever your remainder is coming equivalent to 0, in that case your divisor and your quotient both are factors of your dividend. What we will conclude over here, that 3 and 4 are factors of 12. Similarly, if I say that if I am going to divide 15 by say 5, then what we will be getting? 5 3s are 15 and your remainder will be 0 in this case also. So whensoever your remainder is 0, we say that your divisor and your quotient both are factors of your dividend. That means 5 and 3 are factors of your 15. That means remainder should be 0. Now, if I am saying x minus a is a factor of px, so when your x minus a will be factor of px, for that condition your remainder should be equivalent to 0, then only x minus a will be the your factor of your px. That means x minus a will be factor if pa remainder will be 0. If it is 0, in that case this will be the factor of your px. That is only, it is written over here that x minus a is a factor of px if pa is 0. If remainder is 0, then your x minus a will be factor of your px. And if pa is 0, if x minus a is a factor, if automatically it is given to us that x minus a is a factor, so when it will be a factor, then your remainder will be 0. That simply means if x minus a is the factor of this polynomial px, in that case your remainder will be 0. That means value of pa will be 0. Hope it is clear to you that if we are taking a polynomial px, we are dividing it by any polynomial gx and the quotient is your qx, then gx will be the factor if your remainder rx will be 0 and remainder is equivalent to your pa. Just now in the remainder theorem we have seen it. So if your pa is 0, then x minus a will be factor of your polynomial px. Now we know how to find the factors of your quadratic polynomial. By middle term splitting, we can find the factors of your quadratic polynomial. Say suppose your quadratic polynomial is x square minus of 5x plus of 6. So what we do in middle term splitting, in the middle term splitting, we are splitting the middle term into two parts such that sum should be equivalent to your middle term and product should be equivalent to the product of your first and third term. Here product of first and third term is your 6x square. That means we have to split minus 5x into two parts such that sum should be equivalent to minus 5x and product should be equivalent to your 6x square. So how we can write this? Minus 5x, minus 2x and minus 3x. If we will add minus 2x and minus 3x, we will be getting minus 5x. And if we will be multiplying these two, we will be getting your 6x square. So we will be writing this as x square minus 5x will be written as minus 2x minus 3x plus 6. Now from the first two terms we will be taking common. X could be taken common from the first two terms. Remaining will be your x minus 2. From the last two terms we have to take common. So minus 3 taken common. Remaining will be your x. Here minus 3 multiplied by minus 2 will be plus 6. Here this bracket should be same. Here it is coming same. That means till now the procedure is true, right? It is. Now from this term and this term, x minus 2 could be taken common. Remaining will be your, from here it will be x and from here it is your minus 3. That means factor of this polynomial is your x minus 2 and x minus 3 are the factors of this polynomial. Now how we can get it, the value of this, by your factor theorem. Now see over here, if we will apply the factor theorem, it is x square minus 5x plus 6. Now what we will be looking for, we will be finding the factors of 6 first of all. So factors of 6 could be plus minus 1, plus minus 2, plus minus 3, plus minus 6. This could be the factors of 6. Now we will be trying all these numbers in it. And whensoever your value of this polynomial will become equivalent to 0, that will be the factor of the polynomial. Now let's check it out. If I am going to keep x is equivalent to 1 here, in this, suppose this is your px. If I am going to keep x is equivalent to 1, it will be your p1. So 1 square will be 1 minus 5 plus 6. 1 plus 6 will be 7 minus 5, that is 2. It is not equivalent to 0. That means x is equivalent to 1 is not the factor. Now, that means it is not the 0 basically. Now, if I am going to take x is equivalent to 2, then value of p2 will be, wherever x is coming, I am going to replace it by 2. So 2 square minus 5 into 2 plus 6. 2 2s are 4, minus 5 into 2 will be 10, plus of 6, 6 plus 4 is 10, minus 10, that is your 0. That means if we are going to replace x by 2, then it will be the 0 of this polynomial. If x is equivalent to 2 is the 0 of the polynomial, factor of this polynomial will be your x minus 2 will be the factor of the polynomial, because x minus 2, for x minus 2 only, x is equivalent to 2 is the 0 of this polynomial. So the factor of this polynomial is x minus 2, because at x is equivalent to 2, your value of the polynomial is becoming equivalent to 0. So we can conclude that x minus 2 will be the one of the factor. Now we said that in a quadratic polynomial, we can have two values, two zeros we could have. That means maximum of two values of x will be there, for which your value of the polynomial will turn to 0. One of the value we already got it, that is x is equivalent to 2. Now let's check the another even. Let's take x is equivalent to 3. So p3 will be, 3 square will be your 9, just I am writing it, 3 square minus 5 into 3 plus 6. 3 square will be 9, minus 5 into 3 will be 15 plus 6. 9 plus 6 is 15, minus 15, it is equivalent to 0. That means 3 is even a 0 of this polynomial. If 3 is the 0 of the polynomial, that simply means x minus 3 will be the factor of this polynomial, or we can say that the factor of this polynomial is your x minus 2 and x minus 3. And from here even we get the same value, from here even we get the same value. So for quadratic polynomials, we can use middle term splitting for finding the factors of the given polynomial, or by this method even we can find it out. If it is a cubic polynomial, then for first factor, because we said that in cubic polynomial there could be maximum of 3 factors are possible. Now, if 3 factors are possible or 3 zeros of the polynomial is possible for a cubic polynomial, because its degree is 3, so maximum of 3 zeros are possible for a cubic polynomial. So one of the polynomial we will be getting by trial and error. By this method only we will be finding the factors of the constant, and then we'll be trying these values. Whatsoever the value, your value of the polynomial will become equivalent to 0. It will give the 0. That means if your a is the value for which your polynomial is becoming equivalent to 0, that means if you are going to keep x is equivalent to a and value of the polynomial is becoming equivalent to 0, in that case x minus a will be the factor of the given polynomial. And if at x is equivalent to minus a, your value of the polynomial is becoming equivalent to 0, so when it will come over here, so it will be x plus a will be the factor of the given polynomial. So by this trial and error, we will be getting one of the factor for cubic polynomial, and once we are having the one of the factor of the cubic polynomial, we will be dividing that cubic polynomial and this linear polynomial. If we will be dividing it, the quotient will be your quadratic polynomial, and by middle term splitting again we can find the factors of the quadratic polynomial. So for quadratic polynomial, either of these methods could be used, and for your cubic polynomial, one of the 0 you have to find by your trial and error method. That means by factor theorem only, one of the factor you have to find, one of the 0 of the polynomial you have to find. And once you are having one of the polynomial, one of the factor or one of the 0 of the polynomial, if you will be dividing this factor by your cubic polynomial, you will be getting a quadratic polynomial as a quotient, and by factorization you can find the remaining 2 factors of the cubic polynomial. Now let's understand some of the algebraic identities. What identities are? Identities are the statements which are true in each and every situation. whatsoever the value of the variables will be keeping, for each and every value of the variables, this statement will be true. All these statements will be true. So that's the reason they are known as identities. X plus y whole square, it is equivalent to x square plus 2xy plus y square. Few of these identities we have already learned in our previous classes. This already we have learned. Now x minus y whole square is x square minus 2xy plus y square. Third is your x square minus y square is x plus y, x minus y. Fourth is your x plus a multiplied by x plus b is equivalent to x square plus x in the bracket a plus b plus ab. These four identities we have already learned in our previous classes. Now let's learn some new identities. X plus y plus z whole square, it will be x square plus y square plus z square plus 2xy plus 2yz plus 2xz. X plus y whole cube will be x cube plus 3x square y plus 3xy square plus y cube. Either in this form we can write it, or we can write it in the form x cube plus y cube plus 3xy multiplied by x plus y. Over here from these two terms we have taken 3xy common, and the remaining is your x plus y. X minus y whole cube will be x cube minus 3x square y plus 3xy square minus y cube. Again we can write it from these two terms, we can take minus 3xy common, or this could be written in this form also, or it could be written like x cube minus y cube minus 3xy in the bracket x minus y. The last identity is x cube plus y cube plus z cube minus 3xyz is equivalent to x plus y plus z, and x square plus y square plus z square minus xy minus yz minus xz. Multiplication of these two brackets will be equivalent to your x cube plus y cube plus z cube minus 3xyz. Now over here we can see that if the value of x plus y plus z will become equivalent to 0, this whole part will become equivalent to 0, and that simply means your x cube plus y cube plus z cube will be equivalent to your 3xyz. This is even an important inference, that if your x plus y plus z is equivalent to 0, then x cube plus y cube plus z cube will be equivalent to your 3xyz. We have to remember all these identities by heart. Now let's see how to solve questions based on these identities. If it is your 2a plus 3y minus 4c whole square, this we have to expand. How we will be doing it? We can see over here, this is your ax plus y plus z whole square. We can compare this and this. So we can see over here, if we are going to compare this identity with this given question, we can see that value of x is your 2a, value of y is your 3b, and value of z is your minus of 4c. If we are going to replace in this identity, x is equivalent to 2a, y is equivalent to 3b, and z is equivalent to minus 4c, it will be exactly same, right? So how we will be expanding this? This will be your, first of all we will be writing the identity x plus y plus z whole square, it is equivalent to x square plus y square plus z square plus 2xy plus 2yz plus 2zx. Now instead of x we will be keeping 2a, instead of y we will be keeping 3b, and instead of z we will be keeping minus of 4c. So it could be written as x is your 2a whole square, this will be your 2a plus 3b minus 4c whole square. Y will be your 3b whole square, z is your minus of 4c whole square, plus 2 into x is your 2a, y is your 3b, plus 2 into yz, so 2 into y is your 3b, and z is your minus of 4c, plus 2 of zx, plus 2, z is your minus 4c, and x is your 2a. Now if we will solve it further, it will become 2a square will be 4a square, 3b whole square will be 3 3s are 9, b square, minus 4c whole square will be minus 4 into minus 4 will be plus 16c square. Now 2 into 2 will be 4, and 4 3s are 12, plus 12ab. 2 multiplied by 3 is 6, and 6 minus 4, 6 4 is 24, minus 24bc. 2 multiplied by minus 4 is minus 8, minus 8 into 2 will be minus of 16ac. This will be the expansion of the given question. This is how we will be solving. We will be comparing our question with any of the identity, and we will be replacing accordingly whatsoever is given to us in the question. Accordingly, we will replace it. Now see 105 whole cube. 105 whole cube could even be written as 100 plus 5 whole cube. Right? Now we can see it is your x plus y whole cube. If we are going to compare this question by this x plus y whole cube, we can see if we are going to replace this x by 100 and this y by your 5, this is becoming the identity for your x plus y whole cube. So what the identity is, x plus y whole cube is x cube plus 3x square y plus 3xy square plus y cube. This is the identity. Now replace x is equivalent to 100 and y is equivalent to 5. If we will be keeping this, it will become 100 plus 5 whole cube will be, first is your x cube, that is your 100 cube, plus 3 multiplied by x square, that is 100 square, into y, that is 5, plus 3, x is 100, y is your 5 square, plus y cube means 5 cube. Wheresoever x was coming in the identity, we have replaced that by 100, and wheresoever y was coming, we have replaced it by 5. Now if we will solve it further, it will be cube of 100, that means 1, 2, 3, 4, 5, 6 zeros will come. Then 5 into 3, 5 3s are 15. So it will be 15 and 100 square will be 4 zeros. Then it is your 5 is 25. 25 into 3 will be 75. So 7500 and 5 cube will be 125. If we will be adding all this, we will be getting the cube of your 105. So if we will solve it further, it will be 5 here, then 2, then 1 and 5. It is becoming 6. Then it is your 7. Then it is your 5. Then it is your 1. And then it is 1. So this will be the cube of your 105. Now let's see the third question. 2x minus 3y whole cube. If we are going to see, we can compare this with your x minus y whole cube. Over here, first of all, we will be writing the identity. X minus y whole cube is x cube minus 3x square y plus 3xy square minus of y cube. This is the identity. Here we will be replacing x by your 2x and y by your 3y. When we will replace over here x by 2x and y by 3y, we will be solving your 2x minus 3y whole cube. So it could be written as 2x minus 3y whole cube is x cube means 2x cube minus 3. X square means 2x square into y is your 3y plus 3 into x is 2x and y is your 3y whole square minus of 3y whole cube. If we will solve it further, 2x cube means 2 cube will be 8. So it will be 8x cube. Here square of 2, that is your 4, and 3 and 3 9. 4 9 is 36 minus of 36x square y. Then it is your 3 3s are 9. 9 3s are 27. 27 into 2 will be your 54. 54xy square minus 3 cube will be your 27y cube. This will be the expansion of the given question. That is 2x minus 3y whole cube could be written as this. Now let's see the last question. X cube plus 8y cube plus 27z cube minus 18xyz. So see over here, this could be written as x whole cube plus 2y whole cube plus 3z whole cube minus 3 multiplied by x multiplied by 2y multiplied by 3z. If we will be multiplying these, 3 multiplied by 2 will be 6 and 6 multiplied by 3 will be 18. So minus 18xyz could be written as minus of 3 into x into 2y into 3z. Now if we will see this and this, we can compare these two, right? So we will be using this identity over here. X is equivalent to x only, y is your 2y, z is your 3z. So wheresoever x, we have to keep x only. Instead of y, we will be replacing your 2y. Instead of z, we will be replacing 3z. So first of all, we will be writing the identity x cube plus y cube plus z cube minus 3xyz could be written as x plus y plus z, x square plus y square plus z square minus xy minus yz minus zx. This is the identity zx. So wheresoever x is coming, we will be writing x only. Wheresoever y is coming, we will be writing 2y. Wheresoever z is coming, we will be writing 3z. So expansion will be, this could be written as x plus y plus z, that is x plus 2y plus 3z. Second bracket, x square means x square only, y square means 2y whole square, z square means 3z whole square minus x, y is your 2y, minus y is 2y and z is your 3z, minus z is your 3z and x is your x only. Now if we will solve it further, it will be x plus 2y plus 3z. Another bracket will be x square, 2y square will be 4y square, 3z square will be 9z square, minus of 2 into xy, minus of 2 into 3 will be 6yz, minus of 3xz. This is how we will be solving these type of questions. First of all, we will be checking which identity we could use, and accordingly we will be applying the identity. Hope it is clear to you. Till now we are having the whole chapter we have done, and it is all about from this chapter. Soon we'll be coming with other videos also from your 9th class syllabus, other chapters also. Thank you.